Controlled environment plant production engineering technology education modules are developed and presented by The Ohio State University, Rutgers, the State University of New Jersey, and the University of Arizona, with support from USDA, NEFA, through their Higher Education Challenge Grant program. In this module, we will discuss the topic of product traceability. This module is presented by Dr. Peter Ling and Luke Power of The Ohio State University and Dr. Murat Kassira of the University of Arizona. There are 4 learning objectives in this module on product traceability. By the end of this module, you will be able to explain the benefits of product traceability, describe the Produce Traceability Initiative, know technologies for tracing products, and list key considerations for successful traceability implementation. The first objective is to explain the benefits of product traceability. We will start with a definition of product traceability. This module is defining product traceability as the ability to trace out the path that a product has taken through the supply chain as it moves from producer to consumer. For this task, product labels and corresponding databases of information must be available. The first benefit is informing consumers how a product was produced. Consumers are willing to pay a higher price for organic products or products that are produced using no pesticides. Also, consumers seek products grown sustainably. Sustainable growing includes a minimum discharge of pesticides and fertilizers into the environment. A second benefit is informing consumers where a product originated. Consumers may gravitate or pay more for products grown locally or in a reputable location. Local products have a small carbon footprint. Reputable locations inspire confidence in food safety and quality. A third benefit is that tracing products informs a grower in such a way that he or she can manage dangers from insects, pathogens, and chemical residues. Records that link immediate supplier with immediate consumer enable a grower to stop further contamination. Tracking the supplier of plant material or produce allows a grower to identify where the contaminants came from. Tracking products allows a grower or consumer to identify where contaminants went. A fourth benefit is that a grower can monitor operation efficiency by using a tracking system to observe the flow of materials through the operation in order to become more lean. See the Material Flow and Labor Designs module for more detailed information. A final benefit is that product traceability enables the recall of harmful products. Responsibilities for growers in the food crop sector of horticulture can be more serious due to the human health risks. An efficient recall can save money, human health, lives, and a business's reputation. Take an active role in every step the food takes through the supply chain and maintain records accurately such that they can be provided for review within a short time period. Continuing with the idea of food recall, a study compared field-grown lettuce with greenhouse-grown lettuce. Human illness-causing bacteria were obtained from sampled irrigation water in 47.6% of open field operations. The same bacteria was found in 12% of sampled irrigation water for greenhouse operations. In conclusion, greenhouse operations are less prone to contamination through irrigation water. However, it must be stressed that the greenhouse operations are still susceptible to contamination through irrigation water. The threat of contamination does exist, and that requires growers to be vigilant. The second objective is to describe the Produce Traceability Initiative. The Produce Traceability Initiative, or PTI, is a voluntary program designed to achieve standardized electronic traceability across the supply chain. This initiative is designed to enhance overall supply chain speed and efficiency and narrow the impact of potential recalls. This protects consumers and industry members. Some recognizable participating companies are Dole Food Company, Driscoll Strawberry Associates, Sunkist Growers, Cisco Corporation, the Kroger Company, and Walmart. Purchasing companies such as Walmart will not accept goods if they are not labeled according to the Produce Traceability Initiative. The Produce Traceability Initiative has 7 milestones to implementation. First, obtain a company prefix. A company prefix is a number obtained from the GS1 organization that uniquely identifies your company from others worldwide. Having a company prefix on an item, case, or pallet links that product back to the company. Milestone number 2 is to assign Global Trade Identification Numbers, or GTINs. GTINs are 14-digit numbers. The indicator digit indicates different packing configurations, for example, a single apple versus a bag of apples. The indicator digit is shown as N1 on the image to the right. The next 12 digits are a combination of first, the company prefix, and next, the reference number assigned by the individual company. On the diagram to the right, this is N2 through N13. The reference number can be anything as long as it is unique within the operation. The length of the reference number depends on the length of the company prefix, which will vary depending on the needs of the company. The check digit is used for error detection and is computed based on the other digits and a mathematical algorithm. On the diagram on the right, the check digit is N14. Milestone 3 is to provide GTINs to buyers. Milestone 4 is to show human-readable information such as GTIN and lot or batch number on labels. To the right, we have the format for a basic PTI case label. Milestone number 5 is to encode the GTIN and lot or batch number in a barcode. On the basic PTI case label shown here, you can note the presence of the barcode. Milestone 6 is to read and store information on incoming products. And milestone 7 is to read and store information on outgoing products. Information to help a grower through the Produce Traceability Initiative can be found at http://www.producetraceability.org. Let's look at a case of a company who has committed to the Produce Traceability Initiative. JEMD Farms, a produce grower, had met all 7 milestones for the Produce Traceability Initiative in 2012. The following benefits have been observed: better management of inventory and quicker and easier satisfaction of retailer needs. Becoming PTI compliant has allowed JEMD Farms to better balance supplying what retailers demand and not having too much extra on hand. Positive reputation with retailers through PTI compliance that allows more business electronically and fewer manual transactions. JEMD Farms also has the ability to respond to a recall or withdrawal within seconds. The third objective is to know technologies for tracing products. We will discuss the barcode and radio frequency identification. The barcode is a machine-readable set of bars carrying data. Barcodes encode product numbers, serial numbers, batch numbers, and more. Barcodes are included on the Product Traceability Initiative labels. The barcode is scanned by a camera or laser and comes in many different forms. The EAN UPC family of barcodes can be found on almost every consumer product in the world and carry an identification number. The data bar can hold additional information such as batch number or expiration date. One-dimensional barcodes carry supply chain tracking plus serial numbers and expiration dates. Barcodes similar to the ones you see here often translate into a number or numbers which identifies a record in a database. For example, at a checkout, a database may bring up price as well as plant name and cultural information. Finally, there are two-dimensional barcodes that contain a significant amount of information. In some cases, more than 7,000 numbers or more than 4,000 numbers and letters. The two-dimensional code pictured here can be read with a smartphone and can, for example, direct a customer to a web page with more product information. Radio frequency identification, or RFID, is a wireless system that can be used to track products as they move through a facility or when in transit during transportation. RFID is a three-part system. First, there is the tag. Equip materials to be traced with RFID tags that carry digital identifying information. Different types of tags exist with different abilities, ranges, and prices. For example, active tags use internal batteries to send out their identification signal. Other tags, called passive tags, do not require a battery. They operate by modulating or reflecting the field generated by a device called the reader. The reader uses radio frequency electromagnetic fields to read identification data from a tag placed on or in a material. The tag does not have to be visible on the exterior of the material. Middleware is a computer inventory system that tracks materials through a process. This flowchart demonstrates how RFID is used for tracking produce. Why is RFID gaining popularity in horticulture? RFID is an easy way of tracking the product from its production to its distribution within large selling or storage areas. RFID is a good way to visualize, identify, and therefore more effectively rectify temperature-related problems at the distribution. RFID tags can be programmed to retain, gather, and display information that can be used to improve operations. Let's look at a couple cases where RFID tags were used. The current cost of the tags makes tagging low-value items impractical. However, tagging is attractive for ornamental shrubs such as rose due to their high market value. In fact, any higher value crop could be tracked with RFID. In this case, rose canes were pruned and an RFID tag was inserted into a 2.5 by 40 millimeter hole drilled into the pith. Information stored included nursery, flower grower, cultivar, and rootstock. Tag information links to a database available for web access that holds more in-depth data with regard to botanical information. In another case, benefits of using active RFID tags equipped with temperature sensors were suggested for cut flowers. Easier tracking of product, a way to identify and rectify temperature-related problems in floral distribution, an objective way to estimate product quality, and information can be used to improve business operations. Improved business operations can be made using product information, grower information, transportation firm, receiver time, and intermittent temperature measurements. The fourth objective is to list key considerations for successful traceability implementation. Growers should know and comply with laws pertaining to traceability and labeling, and record growing conditions including agricultural practices, chemicals used, data concerning surrounding areas, environmental characteristics, and events. Growers should also decide on optimal batch size. Large batches are easier to trace, but in the event of a contamination, the entire batch must be recalled. Growers should know where raw materials originated and where products were shipped. Thank you for viewing.